I'm a generalist, but done a lot of work in the oil and gas sector, some in the chemicals space, particularly on pigments. Think of mica, supply chain around that. So I'm aware of some of the technical intricacies of the chemical industry. And in addition to that, we've done a lot of work in hydrogen energy policies around the world. So let me jump straight in there. Give me a sec. I'll project my slides. So I know there's been quite a bit of discussion on green hydrogen on this panel as well as by the government. But let's talk about some basics first. Economics for green hydrogen is still out of whack in the sense it's very expensive. And I want to put this right in front of everybody because that's a reality. At one hopes it will become $2 per kg by 2030. That's the timeline one is working towards. Till then, anything in green hydrogen is going to be extremely expensive. And this needs to be kept in mind in the context of all the announcements that are happening in the public domain. The other piece that is very important is we need to move beyond R&D pilots to large demonstration stage projects as is being done in Europe and Japan. Till then, we are really doing very, very small experimental stage pilots. And the third piece is India offers the opportunity for large scale deployment once the economics is right, so that a supply chain can develop in India linked to the global supply chains for hydrogen. So with these constraints and realities, let's move forward. And I've talked a little bit about this. Last year, quite a few of the global mature economies put out hydrogen policies and ecosystem development strategies around infrastructure development in, let's say, geography advantageous countries like Japan and Korea, where you can do an infra play on hydrogen, even though it's expensive. Whereas other markets like Europe have taken a cluster approach. And this approach is important because it has indications for India. India is large geographically. Should it take an infrastructure perspective or should it take a cluster approach? These are important decisions to be taken. You, of course, see a lot of projects happening at large demonstration stage across the world. And we worked closely with Terry to look at what the use cases could be. So there's a strong use case in industrial use. In transport, heavy duty transport still meets the need, whereas we feel consumer transport is better served by EVs. And we kind of agree with Terry on that. It's important to talk about this because I understand there might be mixed signals about this. Should it be EVs? Where does hydrogen fit in? Should we be talking about FCV, hydrogen FCVs for passenger cars? I mean, these are important considerations to be taken. And in the industrial space, Mr. Samudra talked about all the focus being done by the company on hydrogen. Steel is a very important use case, as is methanol and the refineries. So that's something to be kept in mind. We definitely see them coming on stream by mid 2020s. Then doing a benchmarking of all the policies and the roadmaps that are being implemented around the world, we try to build a hypothesis of what India's green hydrogen roadmap or policy framework could look like, keeping in mind that renewables and EV and battery technology need to fit in with green hydrogen to build a path to net zero carbon pathway. And we did a series of industry consultations, after which some of these recommendations were prepared, and they were then announced in a public function by the Niti Aayog, by Amitabh Khan on 2nd of December. So this is very voluntary inputs given to the government, but hopefully some of this will find mention in our policy. We were very happy to see the finance minister talk about a green hydrogen mission. Though we know there's a lot of work that is required to be done. And before we get into the mission, I think it's important to establish the principles of how this will come about. A public-private partnership framework is extremely important to create a task force that can bring in learnings from the private sector into this. Funding is extremely important. Small funding will not get us to the large demonstration stage projects. And we firmly believe before any auctions can be organized, this is our view, the policy and roadmap needs to be spelled out. We mention this because we hear quite a bit of discussion about auctions and also about industry mandates in the public domain. Inter-government coordination is extremely critical because different ministries and departments are, of course, keen on hydrogen. But as you would have seen from the previous slide, different industries will have different adoption rates. So that needs to be kept in mind as well. Moving on from policy to what could large demonstration projects look like. Again, this is hypothetical, but here are 5 use cases in front of you. Within transport, we talked about heavy duty trucking along a cluster like the Delhi-Mumbai Industrial Corridor, rather than build hydrogen infrastructure around the country. We could also take a cluster approach around ports and industrial clusters around specific industries. And even from a coal gasification piece, and again, quite a bit of good work has been done by JSW and others in this space, in Talcher in Odisha. Municipal biogas is another one where you could probably do green hydrogen fueled by biogas at a fairly small scale. That could be also one way forward. And here's the hypothesis. If we get the policies right with large demonstration projects where private sector participates with the government, we could look at some of these numbers at the bottom that you see as an aspirational target or milestone by 2030. We want to make the point again that this is a technology and use cases which will take time to mature. And whether we hit some of these numbers or somewhere close, that's going to be dictated by how we collaborate as an industry together, along then also with the government, and make sure whatever funding is required is channelized in the right use cases and in the right structures. So with that, I will stop. That's actually the 2 slides I had. Happy to take questions or can hand over to the next speaker. I actually have a question for the participants. We have seen a flurry of announcements being made by the government, different departments. What's the industry's view to that? Are we ready for those sort of discussions?
Let me start, Mr. Deo. I have been talking to several customers, and it will be good that if you could throw some light on that. Some of the big industries are worried about the investment involved. For example, a big refinery to be converted based on hydrogen fuel, starting with solar power. What kind of games you have to play? I mean, how much is the issue whether solar power is available in the state, whether you have to buy land to put solar power plant, or the grid gives the solar power, or then whether to how much money is required to do the front end changes. So I think the approach today from the big companies in India is to make a study. And we as a Thysson Group also are having contracts with the green hydrogen. We've got already 2 contracts, one from America, one from Canada, which is actually being implemented with our technology for electrolyzers. But majority we find in Australia and other places, people are asking us to make a proper study. They pay for that. And by study, then you can get the investment scenario and what is the cost of hydrogen per kg, as you said, $2, whether you're able to reach. Now in India, what I see is that there is already a lot of enthusiasm and people are worried about energy for a long time. And we used to import LNG and fortunately the price came down to $5 per million BTU. But still hydrogen will be cheaper. So now people are looking at it with a kind of interest. But I'm sure they will go for a study first, any of these companies. Whether you hear the joining of 3 big industries like Reliance and Mahindra and Tata's, definitely they will form a group. There will be a group to a steering committee and they will make a proper study. They'll analyze the hydrogen requirement and stuff like that. Whereas the government on its own is talking about 5,000 crore to be given the budget. That will go only for pilot plant. We also have inquiries for a pilot plants, we have inquiries for the pilot methanol plant, for example, green methanol. So I think to really come on the ground, it may take at least 1.5 to 2 years to the real contract for a steel plant or for a chemical plant. This is what I feel. Maybe you know better. You are dealing with so many people. You can throw some light on that.
Yeah, I do want to mention that the industry is already coming together very quickly with different use cases. And as you mentioned, the players coming together to form a coalition of sorts, I think will happen very quickly. And we see that happening very soon, actually. Not just the domestic players, but also the global players joining forces together with the domestic players. I think that's what is needed, because the global players have the technology and the investments to be able to look at these, but we cannot create different standards. It has to be a same set of standards which will evolve. So that's what we are seeing.
Yeah, and the major point here is that there is a global awakening in this field. So the inquiries are like tsunami. There are so many people right from Middle East to Australia to America to Africa are interested, of course, from India. And whether the global technology players are able to handle so much of the flow of inquiries, number one. And number two, if they get the contract, whether they can execute, because they have to also expand their capacities to do that. And let me remind our viewers here that electrolysis of water is not a great situation. I remember in NFL, National Fertilizer Limited, for the ammonia plant, by electrolysis, good old days, about 30 to 40 years back. So this has been a very commonly practiced. Only difference is now we talk about mega scale. What you require a hydrogen for an ammonia plant is not really comparable to the total energy requirement. The hydrogen was used as a raw material to produce ammonia of 1,500 tons per day or something. Here we talk about the energy replacement for a steel plant or a chemical plant or a refinery. It's a massive scale of fabrication of electrolyzer. So people have to increase the capacity, and that will take some time also.
There is a question, sir. What electricity costs will allow hydrogen affordable? And if there is any realistic expenditure available for the next 15 years. So
they will take it.
All the analysis talks about the expectation that we'll be able to hit $2 a kg by 2030. Now, some players are saying that can be achieved by 2027, but it's all hypothetical. It depends on many variables, but I think the consensus view of all the research.
I think Mr. Deo, there's a misunderstanding. He's talking about the cost of power required in India to make it viable, not the cost of hydrogen.
Right. So cost of power, the good news is, solar tariffs are down. So in that sense, I don't have the numbers offhand, but the green hydrogen costs can probably be achieved in a market like India faster than, let's say, Japan, where it's very...
Amit, I can help you there. This is Subramanian Sarma. I think the 70% of the cost of hydrogen production comes from input energy. And if we have to reach $2 per kg, I think it will correspond to almost about 1.5 rupees. Now we are about 1.99, right? Lowest what we have seen. I think 1.4 to 1.5 in that range. If you can bring the solar or actually it is not just solar, it's around the clock. Because, if you want to have a very good efficiency in the electrolyzer, then we need a steady power. So it's like a hybrid. So it has the hybrid cost of production of energy. It could be solar, wind, and the batteries put together. Batteries may be too much. It has to be in the range of about 1.4 to 1.5. So it's not that far.
No,
compared to where it was and what is the massive reduction we have seen in the cost curve. I think we need to go further down. And if you reach around 1.4, 1.5, then we'll have a massive demand pickup for hydrogen.
Sharma, I can add here, when we started solar business, the first price came at 17 rupees a kilowatt.
That's what I'm saying. Yeah.
And from 17, we came down slowly. And about 2 years back, we crossed the thermal power cost.
Great.
We went downward. The last tender, which was submitted by one company, was almost at 1.99, as Mr. Subramanian Sarma said. So that's the lowest price we have come. But there's a room for improvement as you go for a mega scale. I'm sure we'll come to 1.5, 1.6. Definitely.
But as we all know, that last 10% is always the most difficult journey. So
Yeah,
it is not linear, but it happens
absolutely.
in everything in life. So, but it
Absolutely.
should happen.
Yeah.
But on the demand side, I mean, unlike, let's say, other fuels, the cost of transporting hydrogen is prohibitively high. So when we're looking at use cases, those need to be kept in mind.
I think what you said, that there are two models. One is the transportation infrastructure. Second thing is the cluster model. I personally believe that at least the first decade, when the hydrogen picks up in India, it is going to be more of a cluster model where you produce hydrogen close to the users. And with the new government has come up with a beautiful, very wonderful policy now with respect to transmission systems and privatization. So, then it doesn't matter where you produce renewable energy, you can do wheeling. And if the wheeling cost comes down, then you can produce hydrogen at close to the consumer. So that way you reduce cost of transportation. If you add cost of transportation, hydrogen will take much longer to become economically feasible.
Can I add something here, if you permit? That which is in India, we have solar power almost across the country, except Kashmir, maybe, I don't know, north of India, throughout the year. So this is not a big problem for India, but European countries have a big problem actually. And the solution they are talking about is to convert hydrogen to ammonia, which is the simplest way, and transport liquefied ammonia, which has been done by all of us, for all the DAP, NPK plants in India are based on import of ammonia from Qatar and everywhere. So you transport ammonia and then crack the ammonia into hydrogen and nitrogen at the receiver end. And then you generate
But
hydrogen.
Samudra, that will be for the bulk transportation,
Bulk
like from
transportation.
continent to continent. Within the country, it may not be economical.
Not possible. No. So, and India, we are blessed, no issue. But I think the other countries will have this problem, North Europe.
Correct.
So we have a question here from Mr. B. Narayan. What is your view on the safety aspects in handling large quantity of hydrogen in a small area of operation?
So good, Mr. Samudra, you want to go?
Yeah. I think BN Sab, you always ask very specific, pertinent question and puncture us, but don't worry, I got to answer this time.
I can also.
So you are right. Hydrogen has a difficult situation. Under high pressure temperature, it goes to hydrogen embrittlement, and the pores in any grains in the metallurgy of the steel or any non-uniformity can lead to the embrittlement, and the hydrogen will simply flash like a fire. And there are accidents taking place in all the ethylene oxide glycol plant world over. It is known for that fact. But here what we are doing is we will be having mostly the hydrogen produced from this will be at low pressure. It will not be such a high pressure to compress into liquid form. When the reaction takes place in the hydrogenation reactor or the plant, they're operating at much higher pressure of 50 to 150 bar. And under that pressure and temperature, we can get this kind of a risk. But in the normal pressure in the range of 5 to 10 bar, which will be used in energy form for the running of the steel plant, the risk is minimized. But I cannot rule out the risk. And that day we discussed also, how can you talk about hydrogen by vehicles, cars? The piping has to be designed properly, everything has to be designed properly. But we have to take the safety precaution. But this is less dangerous compared to the any hydrogenation process.
So the next question we have is from Bhargav Pandya, sales engineer from Ilya Jabara. How do you see Indian companies' infrastructure to produce, store, transport, and utilize hydrogen safely?
Yeah, that's a study that should be studied by, and there will be guidelines for that. I mean, today, if you look at every energy which is coming, whether electric power or whether you have fuel coming or whether you have liquid fuel or petrol, etc., all have risk. It is not correct to say hydrogen has a risk more than that. In fact, the risk with petrol, diesel is much higher in terms of fire. And hydrogen, as I said, so there will be proper guidelines coming. Like when you had LPG storages, LPG tanks, and LPG cylinder, it's also risky. LPG cylinder is more risky than the hydrogen cylinder, I can tell you that much.
Okay. So I don't see any more questions over here.
Somebody said something?
No, sir.
Okay, but so I think we are in the exciting era now. And this will be the most welcome move for the country like India, which has been starving for energy for decades now. And we have somewhere a solution coming forward, and we should really work hard to ensure that we implement that, and government is supporting it. So that's my concluding remark. So they want to say something in concluding, or Sharma ji?
I think he has dropped out of the chat, sir.
Sharma ji want to say something?
Yeah, I mean, I kind of agree with you. I think there's, and personally, I believe that the epicenter of the hydrogen currently is in Europe, and that's because A is the huge policy support you're getting from the European government, and B is that European countries had invested heavily on offshore energy, offshore wind energy, and they have that now in abundance. So they want to find alternative use, and I think hydrogen becomes a very economical way, or very nice way to sort of build that capability. So I think that's the driver there. But it may not be from an overall cost perspective. I don't think Europe is going to be the main hub. In my view, the epicenter for hydrogen economy is going to be India, because as I said, the 70% of the cost is going to come from input cost, which is the energy cost. And today, India has demonstrated that is the most competitive place in terms of solar energy or wind energy or hybrid energy cost production. So the cost of generation is so competitive, and the demand side, I think, with the economic growth and the large population we have, so there's going to be a huge pickup in demand, and we should be able to bring down that cost curve. So in my view, I'm very bullish that in 5 to 10 years, India will become the epicenter of hydrogen.
So I'll just take one more question from Abhinav Sharma. He has asked, recently IOCL has announced to build green hydrogen plants in Telangana. Are private companies too coming up with the same plan?
See, as we have been discussing, the scale of operation matters in this. And Indian Oil is the biggest refinery company, and they have also in South also refinery plants. So when they go for a larger scale, become economical. As Mr. Dev said, that he warned us at the start, and I appreciate that the cost of the hydrogen production by this route is expensive, and you have to come down not only the capital, also the OPEX cost based on the power which is produced. So I think that to make it more viable, you must go for large capacity. Private people like Reliance or such companies can definitely think of their own facilities. But as you said, the infrastructure is one part, and the second is cluster is second part. And I can tell you that from the model world over, it is good to go for cluster. There is no really competitive situation. It's like electric power today is a cluster concept. You get through grid electric power unless you go for your own power plant. So if electric power can be a cluster concept, why not hydrogen? Let's look at it like this. So I think instead of private companies looking for their own hydrogen source, it's better to go for a cluster concept. And I'm sure the industry around the township or around the industrial park will go for a cluster concept. I think so, in the long range. Later on, it may be when the cost becomes low. Okay.
I have a question from Mr. Parvatalu Damaraju. He's the domain expert from ONGC Energy Center. He's asking, just a second, sir. How much time is expected to make indigenous green electrolytic hydrogen as regards the components and cell manufacturing is concerned?
This question is to my heart, and you are adding a little bit of flavor to that. The electrolyzers are not made in India. Also now we are doing the electrolysis for caustic soda plant, and this requires exotic material like titanium, nickel, iridium, and stuff like that. So from that point of view, it will be now, and it requires very precision type of fabrication. So initially, I would say that we have to import electrolyzer, but as the demand goes up, I'm sure there will be facilities and collaboration to fabricate electrolyzer in India. Today, it is better to go with the proven electrolytic cell and do it. For almost, we are covering now 20% of the electrolysis in India, and almost all the electrolyzers are imported right now. But if the demand goes up, we can set up workshop and then do it. The servicing can be done in India. In our case, we have a subsidiary, collaborative subsidiary at Goa, which is the Dinora factory of Italy. which is our supplier of electrolyzer. They can service it, they can repair. But that is a small way. We are talking about a huge requirement of electrolyzers, large size electrolyzer. So it will take some time. Maybe I would say 5 to 7 years time frame from now, minimum.
So there is a question from Yatin Mahajan from Burli.
Yeah.
Is there any realistic expenditure available for next 15 years, which we have already discussed? What is
I just want to say the estimate from the government is about $44 billion worth of investments. That's what he had said. Yeah.
So the second part is, what is the threshold for electrolyzer to make it competitive, or it is
about
a long way to
go? 20 megawatt.
So that answers the other question. On what scales can we expect electrolytic hydrogen make it economically feasible?
20 megawatt is the present capacity. That depends on country to country, cost of power, and infrastructural cost.
I will just add that sorry, I dropped off because of network connections. But I will add that at a country level, at aggregated level, unless we reach giga scale capacities, we're not really taking the benefit of economies of scale. So, in many ways, the next decade is going to be about moving to numbers which start to make sense. But for that, we need the major players to come together, and that's why the industry coalition approach that we see coming together is very important.
Absolutely.
I just want to add, Samudra, I mean, what you're saying about the electrolyzer, I think maybe you're coming more from alkaline electrolyzer, but as you know, there are a lot of other technologies also in the electrolyzer, like PEM and solid state. And the PM and all is a much more what you call energy carrying capacity. And if that comes, then I think it will not be 5 to 7 years. That technology is far behind your alkaline electrolyzer, but it's catching up. But I think in 2 years' time, if that technology gets commercially in a large scale, then I think we will see a large number of capacity addition happening in 3 to 5 years. I mean, I would say that the timeline will be 3 to 5 years.
Yeah.
But alkaline has a more footprint requirement. So it depends on how many compact designs come up. I think, but there's a lot of work happening around the world.
Yeah.
We have a very interesting question. Why we need to convert electricity to hydrogen when electricity can be safely, easily transmitted and stored? So this question is from Sunil Varshney.
Sunil
Varshney, Senior Manager Proposals, Petrofac International Limited.
Yeah, Mr. Sunil Varshney, of course, this is a very important question for the country. But as I said, when you sign the protocol at Paris, and when you decide to bring down the emissions as well as bring down the global warming by 1.5 degrees centigrade, the only way is to have electricity made from the renewables. We cannot use normal electric power, which is coming from the coal or from the gas or from the lignite, stuff like that, or oil. So then we have to change the raw material for the power, basically. The raw material for power or renewable could be basically solar power or wind power or even nuclear power also. Nuclear power people are worried to go about. So hydropower, wind power, solar power and nuclear power can be termed as the renewables basically. Nuclear not so much, but the other one. And also bio waste also can convert to power. So this is what we have to go for. So power is power finally. Whether you make it from coal or oil or gas or you make for renewable, it is the basis of power which is important here for the future.
And I think one more important point, Samudra, to add is that the hydrogen is just not for one is for the renewable, but I think the second important is that it is also in steel plants and all, it goes directly as a fuel. If you are able to replace the natural gas, so you are not taking power and converting into hydrogen. If you produce hydrogen, then it becomes also an alternative.
It's a fuel by itself.
Yeah, fuel by itself.
In fact,
and it has also has the ability to produce green derived products like methanol. Then you will have not be having normal. So it's a huge vehicle to sort of decarbonize the world. So it has to be seen in a larger sense.
Exactly. Very good question.
So the next question is, what is the future for fuel cells in India? Are there any R&D activities by Indian companies going on in this domain? This is from Mr. K.S. Vijayaraghavan from Elliott Group.
Yeah, Mr. Vijayaraghavan, this was the promised fuel for almost now 15 years. Ever since we talked about the hydrogen, we always talked about fuel cell. But somehow the fuel cell, they have been very much used in America and Europe to certain scale. If you want to run the house on fuel cell, you can do it. If you want to run a small factory, when you talk about a mega factory, fuel cell operation is not that proven. It is a huge requirement and the cost of the fuel cells is very high. So that option is very capital intensive. And there is no proven technology for such a mega scale. But that is the mother of all the inventions in the hydrogen. Yes, I agree with you.
Again, we have a question from Mr. V. Narayan. Is there a threshold volume of hydrogen that can be stored in a site as we have a rule for storage of chlorine?
There will be, if you under liquefaction, no issue. But if you under high pressure gas, there will be definitely an issue. But I have no idea where to check this, because normally, for example, some of the gases, they don't give more than 4,000 tons or 3,000 tons or 1,000 tons. That could be one of the possibilities.
Mr. Sarma, would you like to add something?
I think there is no such norms have come so far, to my knowledge, for a larger tank.
Yeah, I mean, I agree with Samudra. I think the established norms have not come, but it will come. But it will be very similar to what currently we have for, say, LPG bullets and any source of energy. So it will be determined based on the quantum of energy storage, like how much energy we are stored and what impact it can have. And that is what will govern the volume of storage you have. It will be more dependent on how much energy you are carrying.
That's a very big question, and government must address the issue, because this question will come up in future also. When you have plants where you have to store hydrogen, definitely.
Yeah, but I think the only thing I can add on to is that most likely, as I said before, in large consumers, the hydrogen generation will be very close to consumer. I mean, close to the where the demand is. So that the requirement of the storage is going to be quite less. I mean, that is also another aspect why this clustered model will work, because you can then modulate the generation capacity based on what your demand is. So the need for the storage is not going to be hydrogen, but maybe maybe you need to store water, suppose, for argument's sake, if you are not close to the source of water. So that's the way I see it. I don't think storage will happen in the hydrogen.
The problem comes is when you have a source of hydrogen, something goes wrong there in the plant. Something is wrong. Suddenly you can't stop the steel plant. The hydrogen is supplying. So some small storage will be required to let the system come to the standstill.
Yeah, but that will be quite limited. I mean, then you have to like what you have to have some kind of most of these hydrogen plants are like modules. I mean, it is not like one plant. It is like built-in train. So it is and there are no rotating parts. Yeah, I mean, you are an expert in that. I mean, as Tyson Group. So there are no rotating parts. So the failure rate is more likely whether the energy failure is there. I mean, if there is
only leakage or fire or something.
Yeah, and you can sort of work in different trains. So sudden outage of a whole hydrogen is unlikely from what I have studied. So
very true.
So my next
question. Very good question, Narayan sir. You always start make us think. Thank you very much.
My next question is to Mr. Deo. Do you foresee hydrogen gas grid pan-India in near future? And then Mr. Samudra and Mr. Sarma could comment on this.
Can you repeat the question?
Do you foresee hydrogen gas grid pan-India in near future?
So the cost of infrastructure and transport is massive. And in fact, any approach to build a national grid for hydrogen, I think, is a waste of time and energy. I completely agree with Mr. Sarma's point. Cluster approach is the way to go. And that's why we need to look at Europe. They have made this mistake, starting with a transport use case and now come back towards clusters. We shouldn't look at Japan and Korea. They are completely different cases to India.
But what could happen? What could happen? Just to add on to what Mr. Dev said and Samudra said earlier, is that we already have an existing gas network. We have built a huge gas network, particularly connecting east, west, south, and to some extent, there is a government like they are talking about methanol blending or ethanol blending into liquid fuels for gasolines, etc. There will be a policy change where they will allow certain amount of hydrogen blending into the gas, natural gas. So it is not a full replacement, but it is a slow decarbonization. And that happens, you can use the existing network. So it will be like H natural gas or HLNG and things like that. So that can happen, and that will use the existing network because the cost of transportation will be much lower.
Yeah, but you can imagine we are talking about producing, let's say in India, 32 million tons of ammonia or 25 million tons of ammonia per annum. But if you look at the power coming from the gas, so much. So this kind of a situation will arise only after 30 years from now. What to do with the pipeline question will come up. Right. This big pipelines which are there, you may use for some water or something. I don't know. It will be difficult to think of that.
We still have many questions coming in, but I'll be able to take only one question now. This is from Mr. Parvatalu Damaraju from ONGC Energy Center. Are we linking hydrogen program with CO2 and water to make chemicals and fuels, etc.?
Yeah, well, CO2, capture is a different subject here. Hydrogen is not used for that. It's a different point. But hydrogen has got a lot of other advantages in terms of chemical. Firstly, you can make ammonia. You can make ethanol. These are called green ammonia, green ethanol. And hydrogen can be going as a fuel. Hydrogen also can go for hydrogenation of various organic chemicals. And that's also required. But it's not that big capacity. So hydrogen, and also there's a thought about using hydrogen for the vehicles, transportation. Like Mr. Deo showed you about the hydrogen transportation facilities. So there is going to be a lot of demand for hydrogen from that point of view, not so much in chemical sites in India. Of course, hydrogen goes into the refining. If you look at this, every refinery has a hydrogen plant, and hydrogen is a very basic chemical for all the refining processes, whether it's a DHDS or whether it's a hydrocracker or whatever. So that will be used there also in the refineries.